And the last is the intersection of two lines. Okay, so let's take a look at the intersection of two lines. So we've got here two lines. Line 1 is this one here, -314 plus s times -114, and line 2 is given here as well. We want to find the intersection point between those two lines, if one exists. Remember, this is probably very rare that one would exist if you just chose those lines randomly, okay? Because in three dimensions, this would be a rare case. This would probably be the most common case, two skew lines. But we're going to try and find the intersection anyways. Okay, so I do this algebraically to find out what's going on. So we're going to convert them to parametric form because it's easier to look at the individual coordinates. Okay, so by converting them all to parametric form, here's the equations that we get. Okay. And you want to compare the x's, y's, and z's. So if you want to try this now, you want to pause the video and take it, give it a shot, and then come back to it to see the solution. Okay, so when you compare the two, I've got line 1 and line 2 here, and I'm going to compare them. So the x coordinate for the line equals the x coordinate for the plane, and or x coordinate for line 1 equals the x coordinate for line 2, and so on. And then I rearrange these. I bring the s's to one side. You can bring the s's to the other side. I just decided to bring the s's all to the left side here. So I bring the s's to the left side, and I solve, I bring the constants together and solve them all so I have all the s's on one side. Now I'm going to compare 1 and 2. Okay, so I'm going to substitute in for s in equation 2 into 1 and solve for t. Then I'll get some values for s and t using 1 and 2 because I have two equations with two unknowns. And when you solve that, you'll have values for s and t, but you have to check them in the third equation. In order for there to be an intersection point, the value for s and t has to satisfy all three equations. Okay, so by solving for s and t here, we're going to compare 1 and 2, and we work through it. We get t equal to t equal to 7 over 5. Sub that into 2, and you'll get s equal to 22 over 5. Okay. Now you have to do a formal check of s and t in equation 3. Now I've checked it, it doesn't work. You should also check it, but you need to do a formal check. So you need to check the left side of the equation and the right side. So sub in s into the left side, check, see what it equals, sub in t into the right side, see what it equals, and if they're equal to the same thing, great, you got a point of intersection. If they don't, then you don't have an s and t that satisfies all three equations, and you don't have a point of intersection. Okay, so there's another example on page 493 that's you should look at, example 5. Okay, and that's it for that.